Download this code from codegive.com, link in the description below. Copying and reusing hl7 v2 production components, a deep dive. This tutorial delves into the strategies, techniques, and best practices for copying and reusing hl7 v2 production components. We'll explore different approaches, focusing on code examples in Java, but principles apply broadly, discuss associated challenges, and cover considerations for long-term maintainability. Why reuse hl7 components? Reusing hl7 components offers numerous benefits. Reduce development time. Avoid reinventing the wheel. Leveraging existing, well-tested code significantly speeds up the development process. Improved code quality. Pre-built components that have been proven in production are likely more robust and have fewer bugs than newly written code. Increased consistency. Reusing components ensures consistent handling of hl7 messages across different systems or interfaces, leading to more reliable data exchange. Lower maintenance costs. Maintaining a single, well-managed component repository is far more efficient than maintaining multiple, slightly different versions of the same functionality. Enhanced compliance. If your components are built with specific standards or regulatory requirements in mind, example HIPAA, reusing them helps ensure ongoing compliance. Key considerations before reusing. Before diving into the how, carefully consider these factors. Scope and context. Understand the original component's intended purpose, input/output format, and specific context within the original system. Will it fit seamlessly into the new environment? Dependencies. Identify all dependencies, libraries, databases, external services, of the component. Are these dependencies available and compatible with the target system? Customization needs. Will the component require modification to adapt to the new requirements? If so, carefully assess the extent of these modifications and their impact on the component's original functionality. Excessive modification might negate the benefits of reuse. Versioning and maintainability. Establish a clear versioning scheme for your components and develop a strategy for managing updates and bug fixes. This is crucial for ensuring that reused components remain reliable over time. Testing. Thoroughly test the reused component in the new environment to ensure it functions correctly and integrates seamlessly with the existing systems. Don't assume it will work perfectly just because it worked elsewhere. Licensing. Check the licensing of the original component, especially if it's from a third-party vendor or open-source project. Ensure that the license allows for reuse in your target environment. Documentation. Proper documentation is crucial. Make sure you have adequate documentation for the component, including its purpose, usage instructions, input/output formats, and any known limitations. Approaches to reusing hl7 components. Here are several approaches to reusing hl7 components, ranked roughly from simplest to most complex, each with its own advantages and disadvantages. 1. Copy-paste, and modify, avoid if possible. Description. The most basic approach, directly copy the code from the original component and paste it into the new system. Then modify it to fit the new requirements. Advantages. Simple and quick. Disadvantages. High risk of introducing errors, difficult to maintain, violates the dry, don't repeat yourself, principle. Any bug fixes or updates made to the original component will not be automatically reflected in the copied version. This approach is generally discouraged, especially for complex or critical components. Example, Java. Why it's bad. Imagine a bug is found in getValue method. you would need to fix it in original segment parser and then manually propagate the fix to new segment parser. Very error prone. 2. Code extraction and refactoring, recommended. Description identify the specific code logic you need to reuse from the original component and extract it into a separate, independent function or class. Refactor the code to make it more generic and reusable. This often involves parameterizing the code, removing hard-coded values, and improving its overall structure. Advantages promotes modularity, improves code quality, and makes the reused code easier to maintain. Adheres to the dry principle. Allows for customization without directly modifying the original component. Disadvantages requires more effort upfront. Requires a good understanding of the original code and refactoring principles. Example, Java. Improvements. The hl7 utils class contains a generic function that can be reused in many contexts. New component now has more specific methods tailored to the hl7 structure, making the code more readable and maintainable. If a bug is found in hl7 utils.getValue, fixing it there automatically fixes it everywhere it's used. 3. Inheritance, object-oriented approach. Description. If the original component is an object-oriented class, you can use inheritance to create a new class that inherits the functionality of the original class. You can then override methods or add new methods to customize the inherited functionality. Advantages. Promotes code reuse and provides a clear hierarchical structure. Allows for specialization of the original component's functionality. Disadvantages. Can lead to tight coupling between the parent and child classes. Requires a good understanding of object-oriented principles. Can become complex if the inheritance hierarchy becomes too deep. Example, Java. Benefits. The ADT-hl7 processor class reuses the getSegment method from the base hl7 processor class. It overrides the process message method to provide specific processing logic for ADT messages. It leverages hl7 utils for extracting field values. 4. Composition, object-oriented approach, preferred over inheritance. Description. Instead of inheriting from the original component, you can create a new component that contains an instance of the original component as a field, has a relationship. This allows you to reuse the original component's functionality without tightly coupling your new component to its implementation. You can then delegate calls to the original component's methods as needed. Advantages. More flexible than inheritance. Reduces coupling between components. Promotes better encapsulation. Often considered a better design principle than inheritance for reuse. Disadvantages. Requires more initial setup. Can result in slightly more verbose code. Example, Java. Advantages. The ADT message handler has a hl7 message parser. It delegates the task of parsing to the hl7 message parser component. This provides more flexibility and looser coupling. 5. Shared libraries/modules, highly recommended. Description. The most robust and maintainable approach, encapsulate reusable hl7 components into shared libraries or modules. These libraries can then be deployed and used by multiple systems. This approach provides a single source of truth for the reusable components, ensuring consistency and simplifying maintenance. Advantages. Promotes maximum code reuse, simplifies maintenance, ensures consistency across systems. Provides a centralized repository for hl7 components. Disadvantages. Requires more upfront planning and infrastructure. Requires a robust build and deployment process. Implementation, conceptual. 1. Create a shared library. Package your reusable hl7 code, example hl7 utils, hl7 message parser from previous examples, into a jar file, Java, or equivalent for other languages. 2. Version control. Use a version control system, example Git, to manage the library's code. 3. Artifact repository. Deploy the jar file to a central artifact repository, example Maven Central, Nexus, Artifactory. 4. Dependency management. In your new project, declare a dependency on the shared library using your build system, example Maven, Gradle. This will automatically download the library and make it available to your code. Example, Maven. Benefits. When the library is updated, example bug fixes, any project using the library can simply update their dependency to the latest version, ensuring that they are using the most up-to-date code. 6. Microservices architecture. Description. Decompose hl7 processing logic into small, independent services. Each service handles a specific task, example message validation, transformation, routing. These services can be deployed and scaled independently, providing a highly flexible and resilient architecture. Advantages. Increased modularity, scalability, and fault tolerance. Enables independent development and deployment of components. Facilitates integration with other systems via APIs. Disadvantages. Requires a more complex infrastructure and management. Introduces overhead for inter-service communication. Requires careful design to ensure data consistency. Example, conceptual. hl7 validation service. Receives an hl7 message, validates its structure and content, and returns a validation report. hl7 transformation service. Transforms an hl7 message from one format to another, example hl7v2 to hl7fhir. hl7 routing service. Routes an hl7 message to the appropriate destination system based on its content or other criteria. Code example, validating hl7 message against a structure, Java. Let's expand on one of the examples to create a reusable component for validating hl7 messages against a predefined structure, simplified for demonstration purposes. Explanation. 1 uses happy. This example uses the happy hl7 API library, a widely used Java library for working with hl7 messages. You'll need to add happy as a dependency to your project. Add to your pom.xml in Maven project. 2. hl7 validator class. This class encapsulates the hl7 validation logic. 3. Create validation context. Method * creates a validation context object that defines the validation rules. This example creates a custom validation context using Happy's validation rule builder. This is where you define what makes your messages valid or invalid. You can create different validation contexts for different message types or scenarios. 4. Is valid, method *. Parses the hl7 message using the happy parser. Sets the custom validation context into happy for validation. Calls the happy message.isValid method, which uses the validation context to perform the validation. Returns true if the message is valid, false otherwise. 5. Main method demonstrates how to use the hl7 validator class to validate hl7 messages. How to reuse this component 1. Package as a shared library as mentioned earlier, package the hl7 validator class and its dependencies, especially happy, into a jar file. To deploy to artifact repository * deploy the jar file to a central artifact repository, example Maven Central, Nexus, Artifactory. 3. Add as dependency * add the jar file as a dependency to your other hl7 processing projects. Customization and extensibility * different validation rules * create different validation context objects for different hl7 message types or scenarios. You could load the validation rules from configuration files to make the component even more flexible. Custom error handling modify the isValid method to provide more detailed error messages or logging information when validation fails. Integration with hl7 processing pipelines integrate the hl7 validator into your hl7 processing pipelines to ensure that only valid messages are processed. Challenges and considerations *hl7 complexity *hl7 is a complex standard with many variations and optional fields. Creating comprehensive validation rules can be challenging. Performance *hl7 validation can be computationally expensive, especially for large messages. Optimize your code and validation rules to minimize the impact on performance. Version compatibility ensure that your hl7 components are compatible with the specific hl7 versions used by your systems. Data mapping hl7 messages often contain complex data structures that need to be mapped to other systems. Reusable data mapping components can help to simplify this process. Dynamic validation if your validation requirements change frequently, consider using a rules engine or other dynamic validation framework. Best practices for reusing hl7 components keep it simple design your reusable components to be as simple and focused as possible. Document everything provide clear and comprehensive documentation for your reusable components. Test thoroughly thoroughly test your reusable components in different environments and with different types of hl7 messages. Version control use version control to manage your reusable components and track changes. Automate testing implement automated tests to ensure that your reusable components continue to function correctly over time. Refactor regularly refactor your reusable components periodically to improve their design and maintainability. Choose the right tool select hl7 parsing and validation libraries and tools that best fit your needs. Libraries like Happy provide comprehensive support for the hl7 standard and can greatly simplify the development process. Conclusion Copying and reusing hl7 production components is a powerful way to accelerate development, improve code quality, and reduce maintenance costs. By following the strategies and best practices outlined in this tutorial, you can effectively leverage existing hl7 code to build robust and reliable hl7 interfaces. Remember to carefully consider the scope, dependencies, customization needs, and maintainability of the components you reuse, and always test thoroughly to ensure that they function correctly in the target environment. Using approaches like code extraction, composition, and shared libraries will lead to more maintainable and robust solutions than simple copy/paste. Finally, always consider the hl7 version and its impact on the validity and interpretation of the messages. Okay, let's delve into the world of copying and reusing hl7 v2 production components. This is a critical skill for anyone working with healthcare data integration, as it allows you to build robust and efficient systems by leveraging existing work. We'll cover strategies, code examples, and best practices. Core concepts. Before diving into the specifics, let's establish some fundamental principles. Asterisk modularity asterisk hl7 v2 production environments should be built from modular components. This facilitates reuse, testing, and maintainability. Components might include parsers, validators, message generators, transformation engines, routing logic, persistence layers, and error handling routines. Asterisk abstraction asterisk hide implementation details behind well-defined interfaces. This enables you to swap out components without affecting the rest of the system. For example, you might have an interface for a data persistence layer that can be implemented using different databases, example SQL Server, PostgreSQL, MongoDB. Asterisk configuration driven asterisk minimize hard-coded logic. Instead, rely on configuration files or databases to define routing rules, message mappings, and other system behavior. This makes it easier to adapt the system to new requirements without modifying code. Asterisk version control asterisk treat your hl7 v2 components as code. Use a version control system like Git to track changes, manage branches, and revert to previous versions if needed. Asterisk testing asterisk thorough testing is essential. Write unit tests to verify the behavior of individual components, integration tests to ensure components work together correctly, and end-to-end tests to validate the entire system. Strategies for reusing hl7 v2 components. 1. Component libraries, reusable code. Asterisk core logic asterisk extract common logic into reusable classes or functions. For example, you might have a function to normalize names, validate dates, or perform calculations related to lab results. Asterisk parsers asterisk implement robust hl7 parsers that can handle a variety of message formats. Use a library or framework that supports hl7 v2, example Happy, nhappy, hl7 soup, or custom solutions. Wrap the library functionality in your own classes to add domain-specific behavior. Asterisk validators asterisk create a set of validators to enforce data quality rules. These can check for required fields, valid data types, and adherence to specific code sets. Consider using a validation framework or library. Asterisk transformation engines asterisk develop transformation engines that can map data between different hl7 message formats or between hl7 and other data formats, example XML, JSON. Use a mapping tool or language, example XSLT, custom mapping logic. Asterisk error handling asterisk implement a centralized error handling system that can log errors, send alerts, and automatically retry failed operations. Asterisk data access objects, DAOs encapsulate database access logic in DAOs. This makes it easier to switch between databases or change the database schema without affecting the rest of the application. 2. Configuration files and databases asterisk. Asterisk routing rules asterisk define routing rules in configuration files or a database. These rules specify how messages should be routed based on message type, sender, receiver, or other criteria. Asterisk message mappings asterisk store message mappings in configuration files or a database. These mappings define how data should be transformed from one hl7 message format to another or between hl7 and other data formats. Asterisk code sets asterisk load code sets, example ICD-10, SNOMED-CT, from configuration files or a database. This ensures that the system uses consistent code sets and makes it easier to update them. Asterisk validation rules asterisk define validation rules in configuration files or a database. This allows you to easily add or modify validation rules without changing code. 3. Microservices architecture asterisk. Asterisk break down the hl7 v2 production environment into smaller, independent microservices. Each microservice should be responsible for a specific task, such as parsing hl7 messages, validating data, transforming data, or routing messages. Asterisk microservices can be deployed and scaled independently, making the system more resilient and scalable. Asterisk microservices can be written in different programming languages and use different technologies, allowing you to choose the best technology for each task. Asterisk microservices communicate with each other using APIs, example REST, gRPC. This makes it easier to integrate microservices written in different languages and using different technologies. Asterisk each microservice becomes a highly reusable component. For APIs and web services asterisk. Asterisk expose hl7 v2 functionality as APIs or web services. This allows other applications to access and use the functionality without needing to understand the underlying implementation details. Asterisk APIs and web services can be used to integrate hl7 v2 systems with other healthcare systems, such as EMRs, HIs, and payer systems. Asterisk use a standard API format, such as REST, to make it easier for other applications to integrate with the hl7 v2 system. 5 hl7 interface engines, integration engines. Asterisk hl7 interface engines provide a platform for building and deploying hl7 integrations. Asterisk they typically include features such as message parsing, validation, transformation, routing, and persistence. Asterisk interface engines often provide graphical user interfaces for configuring integrations, making it easier to build and maintain them. Asterisk examples include Mirth Connect, Iguana, CorePoint Integration Engine, and others. Asterisk use the engine's mapping and transformation capabilities. Code examples, illustrative, Java using Happy. Let's provide Java examples using the Happy, hl7 API, library for some of the above strategies. These examples are simplified for clarity. You will need to add appropriate exception handling and error logging. 1. Reusable parser component. Key points. Asterisk the hl7 parser class encapsulates the Happy parser. Asterisk parse message, takes an hl7 string and returns a Happy message object. Asterisk encode message, takes a Happy message object and returns an hl7 string. Asterisk you can easily switch between pipe delimited and XML parsers by changing context.getPipeParser to context.getXML parser. 2. Reusable validator component. Key points. Asterisk the hl7 validator class encapsulates validation logic. Asterisk validate, takes a Happy message object and returns a list of error messages. Asterisk validation rules are implemented within the validate method. You can add more rules as needed. Asterisk the example shows how to check for the existence of a segment, the presence of a field, and date validation. 3. Reusable transformation component. Key points. Asterisk the hl7 transformer class encapsulates transformation logic. Asterisk transform, takes a source message object and returns a transformed message object. Asterisk the example shows how to copy data from one message to another. Asterisk more sophisticated transformations can be implemented using mapping rules, XPath expressions, or custom code. 4. Routing based on configuration. Let's imagine a simple configuration file, example routing.properties. And the code. Key points. Asterisk loads routing rules from a routing.properties file. Asterisk get destination, extracts the message type and trigger event from the hl7 message and uses them to look up the destination in the configuration. Asterisk this makes it easy to change routing rules without modifying code. Best practices for component reuse. Design for reuse. When developing components, consider how they can be reused in other contexts. Write clear documentation and provide examples of how to use the components. Keep components small and focused. Each component should have a single, well-defined responsibility. This makes them easier to understand, test, and reuse. Use interfaces. Define interfaces for your components to decouple them from specific implementations. This allows you to swap out implementations without affecting the rest of the system. Use dependency injection. Use dependency injection to manage the dependencies between components. This makes it easier to test and reuse components in different contexts. Version your components. Use version control to track changes to your components. This makes it easier to manage dependencies and ensure that you are using the correct version of a component. Document your components. Provide clear documentation for your components, including information on how to use them, what dependencies they have, and what their limitations are. Establish a component repository. Create a central repository where you can store and share reusable components. This makes it easier for developers to find and use existing components. Follow hl7 standards. Adhere to hl7 standards and best practices to ensure interoperability with other systems. Security considerations. Handle sensitive data, FI, securely. Encrypt data at rest and in transit. Implement access controls to protect data from unauthorized access. Audit logging is also important. Performance testing. Regularly perform performance testing to identify bottlenecks and optimize component performance. hl7 processing can be resource intensive, especially for large messages or high volumes of data. Monitor and alert. Implement monitoring and alerting to detect and respond to errors and performance issues. This can help you proactively identify and resolve problems before they impact the system. Tools and technologies. hl7 libraries. Happy, NHappy, hl7 soup. Interface engines. Mirth Connect, Iguana, CorePoint Integration Engine, Ensemble. Messaging queues. Apache Kafka, RabbitMQ, ActiveMQ. Databases. SQL Server, PostgreSQL, Oracle, MongoDB. API gateways. Kong, APG, Azure API Management. Monitoring tools. Prometheus, Grafana, Elk Stack. Build tools. Maven, Gradle. CI/CD tools. Jenkins, GitLab CI, Azure DevOps. Docker and Kubernetes. Containerization and orchestration. Common challenges. hl7 version differences. Handling different versions of hl7 v2 can be challenging, as there are differences in message structures and data types. Custom hl7 implementations. Many organizations have custom hl7 implementations that deviate from the standard. This can make it difficult to integrate with these systems. Data quality issues. Poor data quality can lead to errors and inconsistencies in hl7 messages. Security concerns. hl7 messages often contain sensitive patient information, so security is a major concern. Performance bottlenecks. hl7 processing can be resource intensive, so performance bottlenecks can be a problem. Conclusion. Copying and reusing hl7 v2 production components is essential for building robust, scalable, and maintainable healthcare data integration systems. By following the strategies and best practices outlined in this tutorial, you can improve the efficiency and effectiveness of your hl7 v2 development efforts. Remember to prioritize modularity, abstraction, configuration, version control, and testing. By embracing these principles, you can create a truly reusable and adaptable hl7 v2 production environment.